Okay, good. So, so far, as I mentioned yesterday, that we have covered the Python basic programming, NumPy library, Pandas library, right? Then there is one more important library called matplotlib, which is for visualization. So we'll cover matplotlib today. Okay, there is one more library, Seaborn. So Seaborn also will cover, but during the statistics class or visualization class. I mean, when we are going to have a dedicated practical session, that time we will cover Seaborn. And today we'll cover matplotlib. Okay, so let's start. How to import matplotlib? Like import matplotlib as this one. I mean, you can like any name you can give. Primarily this function we are going to use matplotlib.pyplot. Okay, this library matplotlib.pyplot. So as PLT, okay, and as you already know, import pandas as PD, right? So in matplotlib there are a lot of functions. Okay, so first let me put the setting style. So how? Okay, so like setting style equal to simple. So this is simple style without grid. Okay, like in Excel we can put plots, right, with grid, without grid, simple, and so many style settings are there. Similarly in Python matplotlib library we have different styles and those things. So suppose let us create a classic style. So plt.style.use classic, we are going to use classic style, this one, like without grid. um, Now let's say we want to plot a sine curve and cos curve. Okay, so import matplotlib.pyplot as PLT, that we already defined. No need to define here again. Or you can define, because we are executing different in different blocks, right? But when you are going to write a complete project code, that time no need to repeat this. You can directly call these functions here only. So that what I mean is, if I put this one here, okay, and I execute it, no need to call this lines. Okay, directly we can put. So plotting like x equal to np dot line space 0 comma 10 comma 100. So what it does is, from 0 to 10 it takes 100 spaces, like say x axis, right? So 0 to 10, 100 spaces. And then we are going to use plt dot plot. This is a simple function, x comma np dot sin x. So x versus this x versus sin x curve. This blue is sin x curve. Okay, and then plt dot plot x comma np dot cos x. So green is cos x curve. So what I'm going to do is, the same plot I'm going to plot both sine curve and cos curve. Okay, and then plt dot show will show the plot. Okay, if we execute this script, okay, this will give us plot like this. Okay, in the same figure, two plots, sine curve, one is sine curve, one is cos curve, and this is x plot. This is respective sine cos and cos x, and y versus x, right? So simple code, you can you have seen, like x equal to np dot line space 0 comma 10 comma 100. We are defining the x-axis, then these are the y-axis, and plotting like plt dot plot x comma np dot sin x, and plt dot plot x comma np dot cos x. If we show the plot, plt dot show, then it will generate the plot and it will show us, right? Clear? uh, Now suppose these are solid lines, right? Now suppose how to change the line styles. So in Python you can change the line styles. So let's see how to change the line styles. X equal to np dot line space 0 comma 10 comma 100, that's for x-axis. Here we are going to like plt dot figure. So what it will do is, initially it will draw this figure without the lines. Okay, and then plt dot plot x comma np dot sin x. Then the next plot, I mean, graph will be plotted, and this one single dash, I mean, hyphen means solid line. This one single hyphen line means solid line, so which is this one, sine curve. And plt dot plot x comma np dot cos x, double dash means dotted line. Okay, so this is like dotted line. So what it is going to do is, it is going to create a blank figure first, and then it will create this sine curve plot with a solid line because I've defined like that, and then it is going to, and then in the same figure it will plot cos uh, x curve also with double hyphen means dashed line. So you see the line style got changed, okay, for cos x curve. So this is the approach by which you can change the line style. I'm showing you the different features of matplotlib so that you can plot as per your need, right? How to save this figure? Like just fig. So this is fig, right? So remember that we have stored this figure in this fig. So fig equal to plt dot figure. So this entire figure has is saved into fig object. So how to save that figure? This object, fig dot save fig. This is the command, save fig. Okay, fig dot save fig. Save fig means save figure. Fig dot save fig, and then you um, give the path to your folder. Okay, C drive, my pictures, my figure dot png or jpg, whatever, dot png or jpg, etc. Okay, so that's how you're going to save the figure. Okay, now now let's say we want to create plots like this, like two plots. Okay, two plots for the comparison, two plots together. Okay, these are two plots together. Earlier in the same figure we were drawing two figures, but now we are creating two figures kind of side by side, or two figures separately but together to have a comparison. This is for sine curve, this is for cos curve. So how to do that? Basically, suppose let's create a figure, blank figure, plt dot figure. Okay, then what we are going to do is that you're going to create two panels. This is first panel, this is second panel. Okay, and how to do that? So plt dot subplot. Okay, so this one, last one is for panel number one, last position panel two is for panel number two. This is for panel one, this is for panel two. And for panel one and panel two, so these are row columns. So first two is row column. So what I'm going to do is plt dot subplot. So these are subplot because this is one plot, this is one plot. Plt dot subplot, then row column, and then panel number. So and then plt dot plot x comma np dot sin x. So what I'm going to I'm instructing the computer that okay, in panel one draw sine curve. Okay, and in panel two, so this is for panel two, in panel two draw cos x curve. Okay, so see, this panel one is going to show us sine x curve, and panel two is going to show us cos x curve. Simple, right? Got it? Any question? Clear? Okay. Now, suppose how could we generate the graph in different using different script? I mean, same like panel two panels and two different graphs. There is one more option like fig comma ax. Okay, plt dot subplots two. So here what I'm going to do is I'm not going to define like row, column, and then panel number. Directly we are putting like plt dot subplots two. That means two subplots will be generated. Okay, and then this ax is working like panel number. So ax0 is panel 1 and ax1 is panel 2. So 0 means index. Okay, so this is 0 index, this is 1 index. So ax0 I'm going to plot sine curve. So ax0 dot plot x comma np dot sine x. So this sine x curve is going to be drawn in ax0. X0 means panel 1. Okay, and ax1 I'm going to draw cos x curve. So x1 dot plot x comma np dot cos x, this one, right? So earlier we created the subplots using different scripts, but now we are going to create it using separate script. Now say in statistics there are multiple plots. Okay, in statistics there are multiple plots like line plot, pie chart, histogram, bar diagram. Okay, so let's see how to draw those line plots, area plots, histogram, pi diagram separately. So let's proceed with line plot first. Okay. Okay. So remember this line percentage matplotlib inline. This means that whatever output we are going to generate, these outputs should be coming within this Jupyter notebook itself, within this uh, notebook itself. That's the code percentage matplotlib and then inline. Okay. So like like import matplotlib.pyplot as PLT. No need to define this also because we have already defined earlier. Okay. Now we are going to choose a different style. Like plt.style.use. We used earlier classic, but now we are going to use seaborn white grid. Okay. So what is the style about? This is the style. Just want to show you. Seaborn uh, white grid is this is the style. That style we are going to use it. Okay. Again, this is not required. Okay. So let's use it, generate it. I mean, let's execute it. And now what we are going to do is fig equal to plot.figure. So this blank figure has been generated, right? Fig equal to plot.figure, plt.figure. And we are also going to create the axis. So ax equal to plt.axis, this axis, x-axis and y-axis, without any names this time. This is by default the axis only generated. Okay, like from 0 to 1 and 0 to 1 by default axis. You can change it, the values. Now, now say we are going to draw this sine curve x equal to np dot line space. So now this was by default x curve, x like 0 to 1, but now you are changing the x. You are taking from 0 to 10. Okay, so 0 to 10, I'm putting say 1,000 lines. I mean the space will be like from 0 to 10 like thousand pixels kind of. Okay, so ax dot plot x comma np dot sin x. This is going to finally create the sin x curve. So initially we chose a seaborn white grid style. Then we created a blank figure. Then we created the axis 0 to 1, 0 to 1 by default. Then we changed the x-axis from 0 to 10 with 1,000 pixels or points. And then we are going to finally plot the sin x curve, right? Got it? Okay. Directly without using this all options, you could also use plt dot plot x comma sin x curve. That would have generated this one because you have already defined that I want a C1 white grid, right? And suppose I want to draw both the curves in a single plot. You know how to do it. You just need to repeat this 2 times. plt dot plot once for sin x and plt dot plot twice for cos x. So this will generate sin x curve and cos x curve in the same figure. Figure you have already defined earlier. Okay. Now you can change the line colors. You can change the line colors. How to do that? Suppose I am going to draw 1, 2, 3, 4, 5, 6, 6 curves. Okay. And what are the different 6 curves? First of all, I am going to draw in sine of x and then sine of x minus 1, sine of x minus 2, sine of x minus 3, sine of x minus 4, sine of x minus 5. And I want to choose different colors for these plots. So plt dot plot x comma np dot sine x. Okay. Color equal to blue. This color equal to blue. Plt dot plot x comma np dot sine x minus 1. This is sine x minus 1 curve. Color equal to green. So here I'm going to show you different options to define a color. First, I wrote in full word BLEU, right? So this colors has some simple scripts also like G for green, B for blue, etc., R for red, etc. Okay, this is short codes for the color. And sometimes we can define in PG RGB values also, RGB grayscale value. So grayscale value has 0 to 1. So color equal to 0.75. Sometimes we have hexadecimal codes of the colors. So this is for hexadecimal color. Okay. Sometimes the color are available in RGB format. This is red, this is green, this is blue. Okay. RGB. So color equal to RGB 1.0, 0.2, 0.3. And sometimes HTML colors also can be applied. So color equal to chart reuse. Okay. Now if we execute this will create 6 graphs, and all 6 graphs with multiple colors. Okay, pretty easy. You know how to change the colors, how to plot it, right? Hope it's clear, all of you. I mean, you can write yes if it's clear, no if it's not, in chat box. Is it clear? Okay. Now, similar to changing the colors, okay, I can change the line style also. How to change the line style? So remember, to change the color, the script is color equal to, and to change the line style, the color code equal to line style equal to. Okay. So same as earlier, plt.plot x comma x plus 0. Now we are not going to draw sin x curve. We are going to draw x versus x. We are going to draw x versus x plus 1. Okay, x versus x plus 2, x versus x plus 3, and so on. So line style equal to solid. Okay, these are full word. Line style equal to dashed. Line style equal to dash dot. Line style equal to dotted. So the same thing would have been written using short code, short symbols. Okay, what are the symbols? This symbol is for solid line. Double hyphen is for dashed line. Hyphen dot is for dash dot line, and this colon is for dotted line. Okay, let's execute this. Okay, see, solid line, dash dot line, then dotted line, right? Okay, so now without mentioning color equal to, you can directly use the codes as well as the line in a single format. All right, so this is like solid green. So this hyphen G means solid green. This double hyphen C means dashed cyan. Okay. Hyphen dot K means dash dot black, and colon R means dotted red. Okay. So without using color equal to, without using line style equal to, directly you can change the line style and color. So plt dot plot x comma x plus 0, and then inside quotation minus G means solid green. Inside quotation hyphen C means dashed cyan. Inside quotation hyphen dot K means dash dot black, and inside quotation uh, colon R means dotted red. Okay, so let's execute this. Check. It is changing the line style also. It is changing the color also together. Okay. So good. Now we know how to change the line style. We know how to change the color of the graph. Now let's say how to change the x-axis limits and y-axis limits. Okay. So basically, let's say plt dot plot x comma np dot sin x and plt dot x lim. Okay. So x lim is for changing the x limit. I mean, limit means the values. Okay, values until the range. Range also you can change it. Similarly, you can change the range of y, and you can define the spaces also. Like here, I'm defining like 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, etc. Right? Here I'm defining like minus 1.5 to minus 1, then minus 1, 0 0.5, then 0, then 0 0.5. So 0.5 break. Here 2 break, right? So that we can define here. plt.xlim minus 1, comma 11. This is, I'm just choosing the range. Automatically Python will be taking care of the breaks. And here I'm choosing like plt.ylim minus 1.5 to 1.5. Automatically Python will be choosing the breaks. But we can define also. Okay. If we execute this, the x limit and y limit will be changed. Okay, and accordingly the plot will be generated. Okay, sine curve. This is again sine curve. Okay, got it. Now got it. So clear. Okay. Now how to reverse this graph? How to reverse this graph? Remember, in so far we have plotted like x comma and px. Now if you reverse this, the graph also will be reversed. So if you do like plt dot plot np dot sin x, this is the first one, and this a y position x to be y position, then this curve will be reversed. Okay. So like plt dot plot x comma np dot my okay. One more is like how you can reverse it. Like you are drawing the plot originally, but you are just changing the y limit. Okay, x limit equal to 10 comma 0, like higher range to lower range. Initially we defined like lower range to higher range, right? Here say higher range to lower range, and here also higher range to lower range. That will also reverse the plot. So if you execute this, the sine curve will be reversed. Okay. Okay. Now suppose you want to define the x limb and y limb in the same line. Okay. So this is the script like plt.plot x comma np.sin x plt.axis. If you define like this, sorry, if you define like this plt.axis, then -1 comma 11, this will be for x, and -1.5 comma 1.5, this will be for y. In a single line, you are changing the x limits and y limits. Got it? Let's execute it. Okay, the same code which we are used earlier. We are using different script, and the same plot is being generated, right? Okay, now suppose I here some gaps is coming, right? This one, some gaps before the curve, some graph, some space is there. I want to remove the space. Okay, how to do it? Like plt.axis tight. If we execute this line, plt.axis tight. So this is tightening the graph without any space. Remember earlier we had space this side, this side, this side, this side. Now space is not there. We have tight curve. Okay. This is not that much needed, just to show you like different features. Okay. Now suppose I want to maintain equal aspect, like in if you know about plot, so there are aspect ratio in figure, right? Like if you hope you have seen, like if you want to edit your photo, the aspect ratio is there in Word, right? Microsoft Word. And if you change say height, the automatically width is also getting changed because the aspect ratio, right? Suppose you want to maintain that aspect ratio in Python. How to do that? So this is the command plt.axis equal. So if you want to use equal aspect ratio from both the x-axis and y-axis, so like plt.axis equal, if you put this command, this is going to give you equal aspect ratio. So see this curve and see this curve. Here we are having equal aspect ratio. That's why it's smoothing the curve. Okay, got it. Now what's the next part? Like I want to change the levels of x-axis, y-axis, title, etc. Okay, how to do that? plt dot plot x comma np dot sin x, and then plt dot title. This is for plot title. This will be placed here somewhere in between here. Okay, then plt dot x level. This is to change the x-axis title. This one. plt dot y level. This is to change the y level axis. This one. Earlier we did not have any title, right, for x-axis or y-axis as well as the plot. Now we are going to define three titles for my plot as well as x-axis as well as y-axis, and these are different comments: plt.title, plt.x level, plt.y level. So title is a sine curve which is placed here. X level is x, and say plot y level as sine x. Okay, so if you execute it, so a sine curve. This came from plot title. X level, x-axis level is x. Okay, this one x, and y-axis level is sine x. So sine x. Got it? Okay. Now let's say okay. Suppose you want to create some levels like plot levels, legends. Like these are legends, right? So you want to show to the visualizer or the layman or the person, like, okay, my green box, I mean green curve is sine x curve, and my dotted curve is cos x curve. Okay, so if you want to put like this, what is the format? plt dot plot x comma np dot sin x minus. Okay, what is this about? Who can tell me? Inside single quote minus g. What is this about?
About color.
Color
Yes,
and line pattern.
yes, both. Good, great that you are remembering. So and understanding also. So minus g means solid line and solid green line. solid green line. That's why solid green line. And who can tell me like single quote in colon B?
Dotted blue.
Yes,
Dotted and blue color.
excellent. Yeah, right. Okay, now here we are putting like level equal to sine x and level equal to cos x. Okay, directly we are changing the level of x-axis and directly we are changing the level of y-axis. And we are showing that okay, plt dot legend also. Okay, so plt dot axis equal to what it does is I mentioned this is maintaining the equal aspect ratio. That's why both the curves is smoothing. Okay, if you consider x-axis, y-axis, both are smoothing because of this plt dot axis equal. This is making equal aspect ratio, and plt dot legend will be plotting the legend sin x and cos x. Let's execute. plt dot legend is showing these things like this. So this is easier to understand. Earlier we were not understanding, right? And we do not know what curve is this type, right? So now we are plotting the legend, putting the legend, so people will understand. Okay, my solid green is sin x curve, and dotted blue is cos x curve. Okay. Now, so far we are defining all the things at one. I mean, by manually, right? Customized way. Now, suppose we want to set everything in a single block. How to do that? Ax equal to plt dot axis. I told you that this is going to create the axis by default axis. Then ax dot plot x dot. So this will plot this curve. Okay. Now this is the line which is going to set everything at once. So x lim equal to 0, 10, x limit set, y lim equal to minus 2, 2 set, I mean the limit, x level equal to x set, y level equal to sin x set, title equal to a simple plot set. So everything we are going to define in this same. Okay, so this looks better because we have space, right? So what we are going to do is x dot set x limit equal to this one, y limit equal to this one, x level equal to x, y level equal to sin x, title equal to this one. Now let's execute it. So automatically everything has been put by this single line, right? Got it? So we are setting all the properties in a single line. Okay, so that's about line plot. So this is like working as line, right? So this is about line plot. So what about area plot? So area plot will be like this one. It gives you some area, right? Okay, like some you have seen like plots in villages, right? So this is like area. Um, okay, some farming plots, right? Now say let create a data frame df equal to pd dot data frame sales signups and visits. Okay, and we are putting index equal to pd dot range start equal to this one. So this is index equal to row index, right? If you remember. So row index I'm going to put dates. Okay, the dates will start from 1st January 2018 till 1st July 2018. Okay, and what we are going to do is ax equal to df dot plot dot area. This is the comment for area plot. Ax equal to df, this data frame dot plot, okay, dot area. So what it does is these are numeric values, numeric columns, sales, signups, and visits. Automatically for all numeric variables it will be plotting. So this is for sales, blue, green for signups, and red for visits. Okay, so this is called area plot. So first we created a data frame, and for all the data frame, for all the numeric columns, we are generating area plots, and automatically it created area plots for all the three numeric variables, right? And for all the three numeric variables, by default Python will take care, like it will use different colors so that a layman can understand. Okay. Okay, so this is also called stack diagram because it shows a clear separator, right? Now say I want to unstack it. So what is the unstack? X equal to df dot plot dot area stacked equal to false. If we put it, so it will, I mean, though you can see some color, but it's not that much prompt. Okay, so this is unstacked plot, and this is also known as stacked plot. Okay, stacked area plot. This is unstacked area plot. Okay, so that's how you can create the area plots. Okay, I think Google has changed. I mean, Python, Google has installed some new version. So whatever I ran earlier and whatever I'm running this time, it is the visualization is getting better. If you see this one, so let's see. I think it will be better. Yeah, so visualization is getting better. Okay, so that's how we can create stacked area plot and unstacked area plot. Now say we want to plot area plot for a single column. Okay, earlier we directly plotted area plots for all the data frame. I mean, for all the columns in the data frame. Now, if you want to create for a single column, what's the command? X equal to df dot plot dot area, y equal to sales. Okay, this y equal to sales is this y equal to sales is coming from this y equal to sales is coming from df data frame. Okay, so for sales variable, I'm going to create a area plot like this. Similarly, for what are the variables? Sales and signups and visits. Okay, so let's create a plot for signups also. Okay, this is for visits. This plot is for signups and this plot is for visits, right? Okay, so now line plot is covered, area plot is covered. Now let's talk about histogram. Okay, so these are statistical plots. Do not worry about how this plot is getting generated. I will explain you bit, but I will explain you more when we are going to cover statistics class and then statistics practical and so on. As of now, remember histogram looks like this one. So it has x-axis, y-axis. Like every plot has must have x-axis and y-axis, right? In x-axis, it covers some bins. Okay, so this is called bin. This is one, and bin size is of equal length. So this histogram bin size, like say 5, 5, 5, 5, bin size will be of equal length, and this y-axis gives me the frequency. Okay, frequency means the occurrence of the of this class. So suppose this is the bin one. So group one, this is group two, group three, group four, group five, group six, group etc. I mean some intervals like say minus 3.5 till minus 2.5, minus 2.5 till minus 2, minus 2 to minus 1.5 and so on. Okay, these are the ranges. For all the ranges, what is the frequency? So that frequency is being plotted in y-axis, and that creates the histogram. Okay, that's the basic understanding. Now let's see how to create it. So percentage matplotlib inline, we are defining, as I mentioned, like I want to see the graphs inside Jupyter notebook itself. That's why this line is important, because we have defined this earlier. If you delete it, it won't impact, but let's keep it. Okay, import matplotlib.pyplot as plt so that you remember sometimes, right? plt.style.use Sivan white. So this Sivan white, remember earlier you were using Sivan white grid, right? So now without grid, that style is Sivan white. Sivan white. This does not have any grid. Okay, but style is changed. Now data equal to np.random.random 1000. So I'm going to select 1000 random numbers between 0 to 1, and then from those random numbers I'm going to create a histogram. So plt.hist. This is the comment plt.hist for histogram. plt.hist of data. So this is automatically going to create a histogram for us for all the random numbers. Okay, for all the random numbers. So good. So you know how to create a histogram, plt.hist. Okay. Suppose I want a more customized histogram, like say this bins should be reduced, and say color we want to change it. Okay. We want to put some edge color, right? So how can we do that? plt.hist data bins equal to 30. So earlier, remember, I had by default bins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 bins, because we did not define. So Python automatically calculated 10 bins. Okay, now we are going to define bins equal to 30. So what is going to do is, if you calculate this is 30 bins. 1, 2, 3, 4, 5, 6, dot 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 30. Total 30 bins. Okay, alpha equal to 0 0.5. Okay, 0 0.5 is the breaks. Okay, right? His type equal to step field. Step field means, remember this was creating some lines, right? Dividers. But step field there will be no divider. Okay, there will be no lines. Step function like it looks like step, right? Steps in a building. Okay, that's why step field and color equal to still blue. This color equal to still blue. Edge color is none. So this there is no edge color. Okay, if you put it, if you plot it, okay, you know why is going to create an error? Tell me. Who can tell me why is going to create an error?
Data is not defined here
Yeah, why so?
because we haven't given the data as in the value or the input, whatever.
Exactly, because yes, I have not defined the data. That means I have not executed. Though I have the script here, but I have not executed. I have not created the data, right? So
Right.
let me going to create this data. So let me going to execute this one. This will create this C-bound white plot, and then here I am going to create the data. Okay. So data has been created. Now we can put it. Right, it came. Right, got it. So good answer. Who was this actually? Sorry, I'm not checking the names actually. This is
Urmisha.
Avilasha. Punisha. Okay.
Yeah.
Okay, good. So um, now say we want to compare several histograms in a
Uh,
same figure. Yeah, go
Avinash,
ahead. Go ahead.
sorry. Yeah. What is this alpha? You haven't explained here.
Yeah, I told alpha is for this break, like 0.5, 1,
Okay.
right?
Okay.
Yeah,
Okay. Thank you. Thank you. Sorry.
right. No problem. So suppose you want to compare different histograms in a single plot or figure like this. You want to compare different histograms in a single figure. How to do that? Like x1 equal to np dot random normal. So what we are going to do is we are going to create a variable x1, x2, x3, and we are going to generate 1,000 random numbers from a normal distribution. Okay, so normal distribution you may not know. Normal distribution has, I'll cover what is normal distribution in a statistics class. So normal distribution will have two parameters, mean and sigma. Mean is for average and sigma is for standard deviation. Okay, so x1 is taking 1,000 random numbers from a normal distribution with 0 mean and 0.8 standard deviation. X2 is generating, I mean, taking 1,000 random numbers from a normal distribution with -2 mean and 1 standard deviation. X3 is taking 1,000 random numbers from 3 mean and 2 standard deviation. So that's how we are getting x1, x2, x3, 1,000 data points for each. Now we are defining like quirks. Okay, one object equal to dict. We are putting dictionary, and we are mentioning like his type equal to step field. This step field alpha equal to 0.3. Okay, and beans equal to 40. So 40 beans. So if you plot plt.hist x1 star quirks, this means the parameters is coming from this one. So instead of repeating the parameters, this entire line here, instead of repeating this line for 3 different rows, what we are going to define is we are going to create an object, and that object we are going to call 3 times. So it's much simpler, right? Okay. So plt.hist x1 comma star quirks quirks and quirks. So this is going to call this function, these parameters repeatedly here, here also, here also, here also. So for x1 step field alpha 0.3 means 40, for x2 step field 0.3 40, for x3 also step field 0.3 40. So the graph that I'm going to generate is going to have same style and same pattern and same color. Okay, got it? Right. Now if you execute it, so initially it will create 3 random variables, and then we are going to plot 3 random variables, and we are going to use the same features for all the 3 plots, histograms. Yeah, so really Google or Python has, and Google is using the latest libraries. That's why the graphs are really looking nicer compared to earlier. Okay, so that's all about how you can compare multiple histograms. So two-dimensional histogram, suppose I want to generate two-dimensional histogram. So what is two-dimensional histogram? So like in x-axis, I am having a say different variable, and y-axis I'm having a different variable. Okay, so like from both the angle I can see and the histograms. This side one histogram and this side another histogram. Okay, how to generate that? Like say we are going to define mean equal to 0 comma 0, covariance equal to, I'll define, don't worry, mean, covariance, what are these, I will explain you in statistics class. For now just focus on how we are generating the plots. That's important. So mean equal to 0 0, covariance equal to 1 1 1 1 2. Covariance is basically like joint variance between two variables. Okay, so suppose I have 1 1 and 1 2, so this means like 2 is the variance between x1 and x2. Okay, x suppose I have x1 x2 y1 y2, so like x2 and y2 covariance is 2. So covariance is like joint variance between x and y variable if you have two variables. Okay, now say x comma y equal to np dot random multivariate normal mean comma of comma 10,000. So what I'm going to do is I'm going to generate 10,000 data points for x and y, and this will be a multivariate normal distribution. So single normal distribution looks like by a bell curve, and if we have two variables, then we called it as bivariate normal distribution, and more than two variables, multivariate normal. Okay. So how to create two-dimensional histogram? plt.hist2d. This is the command for two-dimensional histogram. plt.hist2d x comma y. Remember, we are generating two histograms in two-dimensional. So x comma y. So beans equal to 30. So here you are unable to see because 10,000, right? Oh, I mean extensive data points. So maybe let me put 1,000. Okay. So okay, now you can see it a bit clear. Okay. So from this angle, like it will be histogram for x, and from this angle, this will be histogram for y. Okay. The command is plt.hist2d cb equal to plot.color bar. Okay. So color bar is this one. Okay. So color bar, if you put, you will be understanding. Okay. Counts in bin. So counts in bin means like this color is like 16 frequency, those things, right? Okay. So as the deeper the color is, the frequency is higher. That's the meaning. Deeper the color, deeper is the frequency. Okay, lower the color, lower is the frequency. And CV set level counts in bin. So this level we are putting counts in bin. So that is going to create, and CMAP equal to blue. So this is blue color. Okay. So this is going to create a two-dimensional histogram for us. Okay. So that's our two-dimensional histogram. Suppose quickly a histogram for a data frame. We are going to create a data. Okay, different columns. Okay, so so initially I'm not giving any column names. This is only the data points, and then you're going to give column names. Data frame df equal to pd dot data frame data. Then columns equal to empid. So this first column will be empid. Gender. This second column. This first column will be this first column will be employee ID. This second column will be gender. This third column will be age. This fourth column will be sales, and then this will be income. Okay, this will be BMI, this will be income. So if you are going to create this data, and you are going to use like df.hist, what it does is df.hist will create histogram for all the numeric columns. For all the numeric columns, here see we have three numeric columns like age, sales, and income, right? So it will be going to create different histograms for age, sales, and income automatically came, right? So that's how you can plot the histogram for a data frame. Now let's say density plot. So what is density plot? Density plot is like see histogram only, but with the distributional plot. So this is the distribution. In the backend, it has histogram. Okay, histogram we are not showing. I'll show you how to do that. In the backend, it has histogram. So density plot is like this one. This is looking like a density plot, like distribution. This is also called statistical distribution. I mean, what is the pattern actually? What is the pattern of the data? How can we generate it? Say import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, x underscore values, we are defining an object np.random 300. We are going to create a 300 random numbers, and then we are storing in x underscore values. Then df equal to pd.data frame x underscore values, columns equal to var name. So this columns equal to var name, right? And df dot plot kind equal to density. So this is the df dot plot kind equal to density will give me a density plot like this. Okay, that's about density plot for 300 random numbers. Okay. Okay, remember that this pattern got changed. Sorry, just 1 minute. Excuse me. Now, kind equal to density. So who can tell me why this curve changed?
Because of random value, it will change.
Excellent. Who is this?
Urmisha.
Acha, great. Excellent point. Excellent point. So random numbers, as I mentioned earlier also, random number is a random number. And every time you are going to generate the random numbers, it will be different, purely different. Okay, that's why plot is also different. Okay, see, it changed again. See, it changed again. Okay, last time I'm going to show you. Okay, maybe second last time, and this is the last time. Just to show you how it varies. Okay, because of random. Excellent, Misha. Nice, appreciated. So now let's say we are going to read some data from a URL. You already know how to read data from a URL. I have shown you last time in yesterday's class. So from matplotlib import pyplot, from pandas import read underscore CSV. This is the function I mentioned earlier. So load CSV from URL. Okay, you know how to load it from numpy import load txt. So from URL lib request. This is the function that we used earlier. If you remember, import URL open. So URL, this is the complete URL you're going to put. Raw underscore data equal to URL open. Okay, this URL open of this URL. Okay, data set equal to load txt coming from this function load txt of this URL. Okay, this will be reading the data in raw underscore data. Okay, and data set equal to load text raw data comma delimiter equal to comma, because this is a CSV file, right? So comma separated file. So delimiter equal to comma, and names, you are going to give the names of different columns. This data set suppose does not have the names. So names equal to preg plus praise skin and so on. Data equal to pd.data frame data set, this data set. Columns equal to names. You know how to define the columns. Columns equal to names coming from these different columns. Okay. And data dot plot kind equal to density. This is going to plot the density plot. Subplots equal to true. So subplots equal to true means I'm going to create different subplots for different variables. Layout equal to 3 cross 3. So that means 3 cross 3. So here three metrics and 3 metrics, right? Okay. Share x equal to first. This is one more parameter, default parameter for this plot. Okay, density plot. And then pyplot.show, this will be showing me all the plots. So what it's going to do is it's going to create a 3 cross 3 matrix plots. Okay, and then subplots, yes, true, and kind equal to density. So for all the variables like preg class, space, skin, taste, mass, pretty, age class, for all the numerical variables, it is going to give me density plots. That's how it is easier for us to compare, as well as quick plot, matrix plot, right? That's how we can create matrix plot from a data frame, right? Okay, so good. I'm not repeating this. This is same actually. I don't know why I have repeated. Okay, no, I have repeated because earlier I have used load txt, right? This is the function, okay, and data. So now we are directly using under read underscore CSV. So you know how to read a data file, CSV file directly, pandas.read CSV, okay, and then doing the same thing. Okay, so that's about density plot. Now let's move forward quickly. Column diagram. Okay, so what is column diagram? Column diagram looks like this. Column diagram is like individual columns. This is not histogram, but individual columns. Okay, now let's say we have 3 numeric columns and we want to plot column diagrams for all age, sale, and income, so that from the single figure I can compare like what is the age, what is the frequency of age, what is the frequency of sales, what is the frequency of income. for 0, and for one value of x, what is the frequency of this one, right? So that we can compare quickly. How to create that? So df.plot.bar, same data we are using earlier, and it's going to create for different figures, the column diagrams. Okay, this is the column diagrams. Okay, so okay, data. You know why it's happening? Because those are random numbers, those are not frequencies. So what it was going to do is it was going to create several plots. Okay. Okay, so that's how we can create df.plot.bar. This is also called known as bar diagram. Okay, bar diagram or column diagram. So that's how you can generate, right? Suppose I want to plot different, like say age versus sales. Okay, so what is age versus sales? So plt.bar df age and df sales. Okay, so what we are going to do is we are going to draw sales versus age. Okay, I think I have changed the data completely. Okay, so this data, which data, age and sales, 1 minute. Okay, so this is the data frame that we are going to use it. Okay, because after this, I think I have used df somewhere and they changed the complete data. Okay. Okay, now let's see. Okay, yes. Now see, this is going to create column diagrams for sales, signups, and visits. Okay, for different dates. And if we want to create plot for age versus sales, okay, sales versus visits. Sorry, I think that. Okay, suppose X level is sales and Y level is visits. So what it's going to do is it's going to give me visits versus sales, right? Because I have defined like that. They create a bar plot for X visit versus sales, and that's how you can create it. So that's about bar plot. And like what about box plot? Box plot is like, okay, so this is again a statistical plot, but let me explain you. So box plot works like this one. Okay, so it's going to create a box plot. Okay, and box plot is based on quartile 1, quartile 2, and quartile 3. Quartile 1 is q1, like 25% of the values will be between, I mean, less than or equal to that particular value. Q2 means 50% of the observations, total observations will be less than or equal to this value, and Q3 means 75% of the observations will be less than or equal to this value. So that's how box plot is getting generated. And how to create it? df.plot.box. This is going to create box plots for sales, for visits, and signups. Okay, because 3 numeric columns, right? Sales, signups, and visits. Okay, and if you want to create individual box plots, this I created for the entire data frame. You need to use like plt.boxplot and then only the specific variable df income. That is going to give me a single box plot for income. I think income variable is not there. Sorry, this will be sales. Okay, or say visits, whatever, sales, visits, and signups. So this is coming from for sales. Similarly for visits, okay, this is for visit, and similarly for signups, this is the box plot for signups, right? Okay, and now what is pie plot? Pie plot is like pie chart. Most of you may know actually. Pie chart is like this one, percentage distribution plot in a circle, inside a circle. How to create it? plt.pie. Suppose inside the pie plot, I'm going to directly create the data frame and going to use it. Okay, df age levels equal to a b c d e f g h I j. So age column, okay, and age column will have say different levels, I mean different age groups, the age groups, right? Okay, this won't work because the data, I think I have removed it. So, but okay, just to explain you, suppose age group, age, I have different ranges. Okay, suppose 0 to 5 is one range, 5 to 10 is another range, 10 to 15 is another range, 15 to 20 is another range, and so on. So for all the ranges, I have some percentage, right? Suppose 0 to 5 age is 10% of the population. 5 to 10 age is say 20% of the population. Those percentage will be plot here. And here auto PCT equal to percentage 1.18 percentage. What it does is going to create the format. Okay, so like 10.7%, 11.50, 15%, etc. And shadow equal to true. Shadow equal to true is this is going to create some shadow for the pie diagram. See, you can see a clear shadow, right? And plt.show, I'm not running this. This won't run. I need to check like which data frame I have used it. I've changed it in the I think initial. I mean, at the top of the code, I have used this data. Okay. So, but the formula is like age. There are different age groups, and for each group, we have some frequency or percentage, and those percentage will be plotted like this, right? Got it? That's how you create a pie diagram. So, formula is plt.pie. Okay, so similarly for income, suppose I have different income ranges. So DF income levels equal to, suppose these are the different levels that you are going to show, like A, B, C, D, etc. for different different ranges, and then you are going to create this format for this one, like 24.7% and those one. Shadow equal to true. Again, it's going to create the shadow, right? Similarly, you can create for sales also. Okay, this one. Now let's say scatter plot. So this is about pie plot. What is scatter plot? Scatter plot is plotted between two numeric variables when we have more than one variable. So bivariate plot. So this is also known as bivariate plot. So this looks like a scatter plot, like individual points, okay, XY points. How to generate that? Matplotlib inline. So I'm going to show the plot inside the notebook itself. Import matplotlib.pyplot as PLT. Seaborn white grid where we are going to use the style. So seaborn white grid, okay, and same import numpy as np. So x equal to np dot line space 0, 10, 30. So we want like 30 points in between 0 to 10, and y equal to np dot sin x. This is sin x curve, right? And if we plot like plt dot plot x comma y, this o means this one scatter plot. Okay, this o means scatter plot, and color equal to black. So this is going to give me a scatter plot between x and sin x. Okay, so without using this plt dot plot and this option o, we can directly use pandas. Okay, and I mean plt dot scatter also. Plt dot scatter, this function will give me a scatter plot. Df income and df age will give me a scatter plot. Okay, right? So this will be sales. Suppose visits. Okay, yeah, I know why it's going to create error. So this was the earlier data frame, income versus age. Okay, so because the range also got changed. Okay, so scatter plot will be like this one. So what it does is it generates points between income and age. Okay, the plot will be like this one. Okay, so like if I plot income versus sales, this will be the plots, right? So income, suppose I have income 80, and the sales will be say 120, so 80 to 120 point is here. Suppose income is 190 and the sales will be say 117, the point will be here. Like this, individual points will be plotted. So this is called scatter plot, and the function is plt.scatter. Okay. Similarly, if I want to plot sales versus age, plt.scatter sales comma age, this will create scatter plot between sales and age. Okay. Okay. Finally, what is stack plot? I have already covered during area plot. So let's just quickly summarize. Okay. So suppose I'm going to create this year, different years, player one, player two, player three, different variables. Okay. Plt.plot. Okay. This is like in empty list. Okay. Color equal to y, label equal to player one. Plt.plot, color equal to red, label equal to player two, color equal to B for blue, yellow, red, green, and label equal to player three. Plt.stack plot. Here, first where what we are going to do is we are going to plot year and then player one, player two, player three. Okay, this is stack plot. Plt.stack plot, and colors equal to YRB. Okay. So what it will do is, and then we are going to plot the legend also, plt.legend, plt.title equal to goals by 3 players, which is coming here, plt.x level, which is here, coming here, right? plt.y level goals, which will be coming here, and then plot.show. If we show this, this will be creating 3 area plots, one for player one, one for player two, one for player three, so that you can compare, right, the distribution. So that's all about plotting and visualization.